We now discuss the solution of a problem that appeared in the joint entrance examination main held on 26th June 2022 in the second shift. The given question is on the concepts of hyperbola, and the question is from the section coordinate geometry. The given question is, let a line L1 be tangent to the hyperbola x square by 16 minus y square by 4 is equal to 1, and L2 be the line passing through the origin and perpendicular to L1 if the locus of the point of intersection of L1 and L2 is x square plus y square whole square is equal to alpha times x square plus beta times y square, then alpha plus beta is equal to, we are given a parabola x square by 60, a hyperbola x square by 16 minus y square by 4 is equal to 1. And to this hyperbola, L1 is the tangent, and there is another line given to us, that is L2 is a line passing through the origin and is perpendicular to L1, which is the tangent to the hyperbola. If the locus of the point of intersection of the tangent L1 and L2 is x square plus y square whole square is equal to alpha x square plus beta y square, required to find the value of alpha plus beta. That is the given question to us. Now we discuss the solution of the problem in detail. We have the given hyperbola x square by 16 minus y square by 4 is equal to 1, and we have the equation, the standard equation of the hyperbola as x square by a square minus y square by b square is equal to 1. In our context, a square is 16, b square is 4. We are given that L1 is the tangent to the hyperbola, and the tangent to the hyperbola is given by y is equal to mx plus or minus under the square root of a square m square minus b square. In our context, a square is 16, b square is 4. Therefore, the L1 is given by y is equal to mx plus or minus under the square root of 16m square minus 4, and that is the tangent to the given hyperbola. And we are given L2 is the line passing through the origin, okay, and is perpendicular to L1. Because L2 is perpendicular to L1, the product of their slopes must be equal to minus 1. Let the slope of M2 be the slope of L2 be M2, then M2 must be minus 1 by M because they are perpendicular. The slope of L2 is M2 is minus 1 by M, and L2 is passing through the origin. Therefore, the equation of L2 is y is equal to mx, the slope times x. The slope here is minus 1 by mx. Agreed. We know L1, we know L2, and the point of intersection of L1 and L2 is given to be h comma k, and required to find the locus of h comma k. We do it in the next slide. We have the hyperbola, we have the tangent, we have the line L2. Agreed. Let h comma k be the point of intersection of L1 and L2, and required to find the locus of h comma k. Agreed. Because h comma k is the point of intersection of L1 and L2, it lies both on L1 and L2. Therefore, h comma k satisfies both the equations L1 and L2. So that implies and wherever there is y, substitute k, wherever there is x, substitute h, and we get k is equal to mh plus or minus under the square root of 16 m square minus 4. Agreed. And L2 is k is equal to minus h by m. Okay, this implies the first equation is as it is, and from the second equation we write m is equal to minus h by k. Now eliminating m between these two, that means wherever there is m, write h by k, that will give you k is equal to mh will give you minus h square by k plus or minus under the square root of 16 into m square is h square by k square minus 4. So after elimination of the m, we get this one. Now bring that minus h square by k from right hand side to the left hand side. Yes. Now squaring on both sides, we get k plus h square by k whole square is equal to 16 times h square by k square minus 4. Agreed? Agreed. We got this one. So now that means now take the LCM, square it, and send this k whole square to the right hand side. So k square plus h square whole square is equal to k square into 16 times h square by k square minus 4. Agreed. Now this will imply, now multiply k square into 16 times h square by k square cancels, 16h square minus 4k square. Agreed. So that is in terms of hk. Therefore the locus of h comma k is given by replacing h by x and k by y. Thus the locus of h comma k is given by x square plus y square whole square is equal to 16 times x square minus 4y square. But we are given the locus of h comma k as x square plus y square whole square is equal to alpha times x square plus beta times y square. Now comparing both the equations, these are one and the same equations, comparing, then we will get alpha is equal to 16, beta is equal to minus 4. Now what is that we want? We want alpha plus beta. So alpha plus beta is equal to, alpha is 16, beta is minus 4, that will be 12. So the answer to this question is alpha plus beta is equal to 12. That is the detailed discussion of the solution of a problem from the section coordinate geometry, and it is based on the concepts of hyperbola. I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you.